So negative emissions technologies are a whole family of different technologies which are a bit different from other mitigation technologies in that they don't work to reduce emissions, they directly remove carbon dioxide from the air. Now they typically do that in one of two ways, either directly scrubbing carbon dioxide out of the atmosphere or through using biomass, and in a number of different ways. We might need these technologies for at least two reasons. First of all, there are lots of point source emissions that are very difficult to mitigate at source. These include things like motor vehicles, aeroplanes, ships, but also small power plants, small combined heat and power plants and so on, where it makes sense to do the carbon dioxide removal at a different place from where the carbon dioxide is emitted. And the second reason is they provide a way of dealing with an overshoot in emissions. So if we find that CO2 concentrations in the atmosphere have gone too far and we're in danger of accelerating climate change, then we're going to have to do more than just reduce emissions. We're going to have to remove carbon dioxide from the atmosphere to avoid runaway climate change, and that's another really strong reason why we might need them in the future. So geoengineering technologies are divided up into two families. One is solar radiation management, which is in some way interfering with the way in which sunlight comes into the atmosphere through aerosols or mirrors or other devices, and carbon dioxide reduction, which is removing carbon dioxide from the atmosphere. So removing carbon dioxide from the atmosphere doesn't have that kind of direct sort of human change to the weather, which is very unpredictable and which does cause different effects in different parts of the world, which is, I think, one of the big issues of solar radiation management. Carbon dioxide reduction, I think, is actually just part of the spectrum of mitigation technologies, and it is probably best seen as something that can geographically decouple where the emissions are to where you're actually taking the carbon dioxide out of the atmosphere. So in my opinion, I wouldn't really consider it geoengineering. I would consider it part of carbon dioxide emissions mitigation. Currently, the most mature carbon dioxide removal or negative emissions technology are ones based on biomass, and those fall into two main families. One is biomass with carbon capture and storage. That means combusting biomass either on its own or with fossil fuel in a power plant, capturing the emissions and storing them underground, as in CCS, and that is more or less ready to go. The other bio-based technology is using biochar, so it's converting biomass into char, which can be combined with soil and has been shown to have a lifetime in soil of 1,000 years at least. And it has a benefit of improving soil organic carbon and soil productivity. So the main issue with these technologies is not so much the end use, but it's where the biomass comes from. So the biomass, of course, must be sustainably sourced. It must be shown to come from a supply that's low carbon, and it shouldn't interfere with food production. At the moment, these technologies don't have any great market incentives, because the way carbon markets work, there is no incentive to go below zero carbon. And indeed, even today, the incentives to go to low carbon are quite low because carbon prices are relatively low. So the first thing that would need to be done for these technologies to really take off would be to have financial incentives to go below zero, so that the negative portion of the emissions is also given a credit. Second of all, because these technologies are based on some quite complex calculations in terms of how negative the emissions are, and especially if you're using bio-based technologies, you will need some very clear and very auditable life cycle reporting standards. So this is a concern that a lot of people have raised, that this looks like a silver bullet that can avoid us taking hard decisions today so that we can defer the problem to the future. But in reality, we really should be researching these, and I'll explain why. Lots of energy system models, such as those used by the Committee on Climate Change in the UK and the Energy Technologies Institute, indicate that we're going to need some removal of CO2 from the atmosphere, probably through bio-based technologies, by the 2040s. And if those models that they're building already assume that those technologies exist at scale, are being deployed at scale, then it's actually imperative that we're doing research and development today on those technologies so that they're mature enough to be deployed by that time.